Now this one is another composite shape. It's half a circle plus a rectangle. So there's half your circle, there's your rectangle. So another composite shape, and we're going to have to make a construction line to split it into the two shapes we're interested in. So there is the diameter of our semicircle, there's the centre, and we can say something about that distance, which is the radius, and it's going to be half the opposite side of the rectangle, so it'll be 5 centimetres. We also know that, of course, that the distance along there is 16 centimetres. Opposite sides in a rectangle are equal. So if we're asked to find the perimeter of this shape, that's the distance around the outside of the entire shape. So I'll do it this way. We'll say the perimeter is equal to the perimeter around the circular part. I'll draw that again because that doesn't look like a semicircle. So there's the semicircle, and add the perimeter of the 3 sides of the rectangle. Now, the formula for the perimeter of a circle is 2 pi r, but we've only got half a circle, so we can divide that by 2. And the distance around the 3 sides are 2 lengths plus 1 breadth. So there's 1 length, there's the other length, there's the breadth. Now, we do know a little algebra, so we know these 2's will cancel out. 2 divides by 2 to give 1, so we've got pi r times 2l plus 2b, and pi in your calculator, make sure you use it, times 5 plus 2 times 16 plus 10. And if you put these into your calculator and you want to do it all in one step, make sure you force order of operations with those brackets, and it should give you an answer of 57.71, or 57.7 will do. And remember the units of measure, the centimetre. Now to find the area, it's the area of the semicircle, the half circle, plus the area of the rectangle. The area of the semicircle, pi r squared, if let's just make that look a little neater. Pi r squared is the area of a whole circle, but we've got half a circle, so it's pi r squared over 2 plus L times B, the area of the rectangle. Notice how I always write my formulas before I actually start substituting in the values. So pi times 5 squared all over 2 plus 16 times 10 in brackets. Don't forget the brackets round here if you're putting it into your calculator all in one step, and you'll have an answer of 199.3, and remember now it is square measure, so centimetres squared. Now I have a rectangular shape here. It's 6 by 2 centimetres, and I'm asked to calculate its area. So it's length times breadth, which is 6 times 2, and the answer is 12 centimetres squared. Now what if I wanted to convert this area to millimetres squared? It's in centimetres squared at the moment. I want it in millimetres squared. Well, I could have done that by converting 6 centimetres into millimetres by multiplying 6 by 10, so 60 millimetres, and then multiplying the 2 centimetres into millimetres, so 2 times 10, 20 millimetres. So now I have 1200 millimetres squared. Now remember, to convert centimetres to millimetres was multiplied by, to convert centimetres to millimetres was multiplied by 10, but to convert centimetres squared to millimetres squared we had to multiply by 100. Now if you think about it, each one of these little gradations here, if we make 10 little notches along there representing 1 millimetre, and 10 along that side representing another 10 millimetres, and what we have inside that one small square is 100 square millimetres. So that means when we come to look at the table for converting units of area, what we've just looked at is this one, converting centimetres squared to millimetres squared. It's multiplied by 100 or multiplied by 10 squared. So all of these conversions, because we are now looking at square measure, then it's the square of the linear measure. So converting kilometres squared to metres squared is not multiplied by 1,000 but multiplied by 1,000,000. And of course divide by the same quantity along the bottom line. And the last one, that's supposed to be a divide sign. Now there's another unit of measure that is often used for area, and that is the hectare. 1 hectare is 10,000 metres squared, or if you think about it in scientific notation, 10 to the 4 metres squared. So let's just put a nice square around that so we remember that. Okay, so we're going to now do this first example, which is find the area of a 2 kilometre by 7 kilometre paddock. That's a fairly easy one, in kilometres squared. So it's 2 multiplied by 7, length multiplied by breadth. I should really write that formula first. So 14 kilometres squared. If I want to write that in scientific notation and metres squared, First of all, I take the 14 kilometres squared, and to convert kilometres squared to metres squared, that's along the top here, it's multiplied by 10 to the power 6. Now, is that scientific notation? It's not really, because remember we had to have only one digit on the left hand side of the decimal point for scientific notation. Here we've got 2. So we'll have to write the 1 or the 14 as 1.4, and 14 is 1.4 multiplied by 10. Don't forget multiplied by 10 to the 6. Now 10 you can think of as 10 to the power 1 multiplied by 10 to the power 6 using our first index law becomes 1.4 add the powers, so 1.4 multiplied by 10 to the power 7 metres squared. To convert that to hectares, going back up to looking at our rule for hectares, 1 hectare is 10 to the power 4 or 10,000 metres squared. So we've got 1.4 by 10 to the power 7, that's metres squared, and we know every hectare is 10 to the power 4 metres squared. Well, you can think of those two as cancelling out, so we've got 1.4 multiplied by 10 to the power 7 minus 4. You bring up the 10 to the power 4, which is in the denominator, into the numerator. It changes sign. So we've got 1.4 multiplied by 10 to the power 3, and that is now in hectares.